going through the Amazon Dynamo DB paper that was published in I guess 2007. uh, yeah, so we'll basically first of all we'll cover this whole paper in part wise, and in this video I'll cover the requirements part only, uh, and then next we'll see the system architecture of it. So yeah, let's go ahead and we'll see like why this uh, Dynamo DB is needed, why it was needed in the first place, even though there was a lot of databases already available, relational databases and non-relational as well. Then why Amazon did choose to build new database itself. Okay, so yeah, there are few points here in introduction that it talks about, like why there were few scaling challenges as well, right, and then the reliability, failure, and core observation. So what the overall in introduction here, it is talks about the overall after the Dynamo was developed and what they faced, like what were the challenges they faced actually. And the here it was seen that the disk failures were very common and network routing issues were there, and data center outages were also like very normal. uh, then also they noticed that shopping cart service should also be always available. Okay, and the customer should not face any issue during either adding items to cart or removing items from the cart, right? So, and there were few other services which required the service to be always available. Okay, so that's what the core requirement of the Amazon was, and they needed some databases which was very scalable, and it needed to be highly available. It doesn't need to be very consistent. It was uh, it uh, it was okay with eventual consistent system, and it has to be reliable. And the most important thing for the Amazon was to develop this database was to be highly available. Okay, here the it talks about this requirement, like the simple read write operations on single keys, because it if you talk about the relational databases, it provides a lot of complex queries as well. Whereas if we talk about the simple adding items to cart or removing items from the cart, it requires very uh, basic operations like put or get operations. That's it, nothing fancy. So that's what it is basically. That's what encouraged Amdocs, Amazon, to build such database which supports very basic few operations, and it doesn't require complex operations like SQL has. And also it doesn't require this acid functionality. Sacrifices consistency over availability, and the data in this data was mostly blobs, which was less than 1 megabyte. And the SLA, the service level agreement, that was uh, needed is like it must be 99.9th percentile, must be very low latencies. Okay, so he have very low latency. Okay, so if we talk about the design considerations and trade-offs, yeah, let me think. Okay, So the first thing that here it talks about is the problem is like consistency, availability, and reliability cannot be fault tolerance cannot be achieved at the same time. That's what the Cap's theorem is like. Only two of them can be possible at a time. And here the Dynamo DB uh, went with Dynamo went with availability and partition tolerance, right? If we for the relational databases, what was needed was like it it must be strongly consistent. And in distributed system, if we want any database to make it strongly consistent, it must have uh, it must have at least two of the replicas to uh, acknowledge that the read or write has been successful. And in that case, a certain downtime was is possible, because it's possible that a majority of the nodes are down. In that case, the writes will be rejected, and which was against the requirement that Dynamo had. So that's why our traditional approach for like sync replica synchronization was not valid in Amazon's case, right? So what Dynamo went with, eventually consistent system and optimistic replication, and always available for writes. Okay. There was also time when few nodes, if they are taking concurrent writes, in that case, they two of the nodes might have divergent data, and which will cause conflict. And conflict resolution techniques must also be needed to be in place. So Dynamo went with three approaches. First one is this application level conflict resolution, where the client who is going to use this Dynamo will be responsible for handling conflict. And another one was system level conflict resolution. And in this case, the timestamp based uh, right was selected. So in this case, last right wins policy was handled. So let's suppose if there are two nodes, one has written something x equals to a at time t1, and another one has written uh, x equals to b at t2, and t2 is greater than t1. In that case, the valid right that will be, it is x equals to b, right? So that's what system level conflict resolution is. And flexibility is, some apps use application logic and some use timestamp based. Most of the system in Amazon's is like shopping cart and other like catalog. So it depends on the service, whatever they choose. Either they go with the system's default conflict resolution, which is timestamp based, or if we talk about the shopping cart, they choose to go with the application level conflict resolution technique, where they converge the two divergent shopping cart data into one, right? The key design principle in Dynamo's case was incremental scalability. What incremental scalability means is like, so if as the demand uh, of the service grows, or like more data needs to be stored and we need to scale it, then it should be easier to add more nodes as we progress, as our demands in the service increases. So that's what incremental scalability is. So we could keep adding more node as time goes on. And if we talk about the symmetry, the second point over here in the design, it needed that all the node needed to be have an same responsibility, and no no nodes should have a special responsibility. So for example, in relational databases where they follows master slave architecture, and one of them is take write operations and others are allowed for the uh, accepting writes from the leader only, and they are the followers can although accept read operations, but write operations must go through the master, which is also called as active passive architecture. And in that case, one node has more responsibility than the other ones, right? But in Dynamo's case, all nodes are treated as equal. There are no concept of leader or follower. In decentralization, so here peer-to-peer communication protocol needed to be in place because there are no leader who is communicating all the writes happening to the system, and so all each node must be aware of the other system configurations and other nodes writes, right? So for that, peer-to-peer communication needed to be also in place. What it means by heterogeneity is like it should be fine if we add uh, different type of hardware into the cluster. So it should not cause any problem if we add, let's suppose, certain variant of hardware in, and then we again add, let's suppose, more more memory efficient hardware. So for example, if the service is already functioning with commodity hardware, something like let's say 8 gigabytes of RAM, and then we add another hardware, something like 32 gigs of RAM, then the whole system should not be treated as, it should work as smoothly as it is, and it should accept the uh, in, integration of the new hardware should be easier. So that's what the requirement was. Yeah, so that is it. In the next video we'll talk about the system architecture. I'll also link the this white paper into description as well. Thank you.